So we have some running shoes that this athlete wants to replace before they run out of shock absorption capabilities. Zach, being an elite runner, he doesn't want to let his running shoes get too old, so he wants to replace them at a distance when only 25% of people would replace their shoes, before most people would. What we know about these shoes, that there's a mean distance of 640 kilometers, there's a standard deviation of 160, and Zach wants to replace his shoes when only 25% would replace their shoes. So the mean distance, that would give us mu. Standard deviation, that would give us sigma. And Zach's distance would actually be x. So in this case, our 25% gives us z, but only in a way. We need to go back to a z-score table and convert that percentage back into a z-score. So if we look at the table itself, we need to look for 25%, which would not be 25 because this table only goes up to 1. 25% would be 0.25. Now looking, we've got two values that are pretty close to 0.25. Either one would be acceptable to use. I would prefer that you use the closer one. So which of those actually is closer? 0.2514. So then what z-score do we need to look at? Well, it'll start with negative 0.6, and it'll actually be negative 0.67 as our z-score. So now we have to go ahead and just do the math. Can fill in what we know. Z is negative 0.67. X we don't know yet. Mu is 640. And our standard deviation is 160. So to solve this, we need to get x by itself. First step would be to multiply by 160 on both sides to cancel out the denominator on the right. Gives us negative 107.2 on the left. And that equals x minus 640. Second step would be to add 640 to both sides. Cancels that. And it tells us that x is 532.8 kilometers. Why kilometers? Because that's the distance Zach is going to replace his shoes at.